Hello everyone. Today I try to discuss on addition of vector either analytically or graphically. Vector can be add analytically or graphically. These two techniques or methods can help us to add vectors. Today we are see the first method, which is analytical method, which have around 5 basic steps. These are: first step, choose suitable uh, coordinate system. Second step, resolve H vectors. Resolve H vectors. Third step, find the resultant components. Fourth step, find the magnitude of resultant vector using Pythagoras theorem. Fifth steps, applying trigonometric matrix to find the direction with respect to x axis. These are the basic steps helps to analyze vector analytically or mathematically. Applying this, let's exercise upon two given vectors by considering vector A and B are given as shown. That is, this is vector A representation, while if this one is vector B representation. First, we have to choose the suitable coordinate as shown: x, y, Assume this is vector B, while this one is vector A. The two vectors now have their own angle division, which is theta A and theta B. Next step, step 2, resolving H vectors. Step 1, step 2, that is A can have two components by saying that AX, AY, which is A cos theta, AY can have A sin theta. This is just subscribed by A. Subscription is necessary here. For B, B can have resolved in such a manner that Bx and By, while B cos theta, theta of B, and again B sin theta, theta of B again. While the angle of theta A, it is existed somehow a certain theta A, while the angle of B is 0. Theta B is 0. So cos 0, it is 1, implies it gives you B cos theta B, which is 1, where while the value of this theta is equal to theta B is equal to 0 degree, means sine 0 can give a 0 value. 0 times B, it gives you B. The second step is step 2. Step 2, it says that, step 3, it says that finding the resultant component, that is Rx, Ax plus Bx. The value of Ax is A cos theta of A, plus Bx is B, while R of Y, or resultant Y component, is Ay plus By. That is, Ay is expressed by A sin theta of A plus 0. The third step, if it is, the step 4 becomes finding the resultant. The resultant magnitude can be treated by applying Pythagoras theorem. So the Pythagoras theorem, it says that you do have the right angle triangle having its own Rx and Ry. So the resultant is R, implies Rx square plus Ry square is our equation. Here it is, whenever you do have the resultant here is have its own the part which is Ry and again Rx, it means that. So it forms here a right angle triangle, so that you can apply to get this length or magnitude by having this equation. Therefore, R is nothing which is equal to root of Rx square plus Ry square. First, let us square each of the given terms. That means R of x is A times cos theta of A plus B, Whenever you are squaring this becomes square. It means that the value is a cos theta a plus twice of ab cos theta of a plus it is nothing, it is b square. Okay, b square. The value of this square. The next one is squaring ry is best. Its value of ry is a sine theta a, meaning a square sine theta a square. Therefore, substituting these values upon the given r is equal to root of rx square ry square, we can have this one. R is equal to root of, here is Rx, the value R square cos theta A square plus B square plus twice of AB cos theta of A plus the value of this is AY is nothing, ry is nothing, a square sine square theta of a. Here it is, the r is equal to root of the values a square cos theta a square, here is the square for the function, plus a square, b square, I think so, the value of, no, a square sine of theta a square plus b square plus twice of a b cos theta of a. Here it is. The common value for these two terms is a square cos square theta of a plus sine square theta of a plus b square plus twice of ab cos theta of a. Here it is, from your trig identity, the value of this is nothing, it is 1. So my equation becomes a square plus b square plus twice of ab cos theta of a. This is the magnitude of our assumptions vectors or given vectors. So as we know that this is, we have saying by just by saying that a cosine function as a shortcut or some special case we have discussed in previous lesson. Therefore, this is the value, the magnitude. While the last step, step 5, it says that we can determine the direction by applying the trig function. So, from the function of trigonometric functions, we can apply tan theta. The tan theta, it is nothing, it is what? Opposite to adjacent. Adjacent. That is, our opposite of this result is, it is nothing, ry. Adjacent is, it is rx. So tan theta can have a tan inverse of ry by rx. from our step 3, tan inverse of Ry is nothing. It is a cos theta plus b theta of a. That is nothing. It is Ra sine Ra sine theta of a divided by the adjacent one is a cos theta of a plus b. This is the angle. Therefore, finally, to give the answer, R is equal to root of a square plus b square plus twice of ab cos theta of a at an angle of theta is equal to tan inverse of a sine theta a by a cos theta a plus b value. Okay, for today we are seeing all the analytical technique to add vectors. For the next period, we can see how to add vectors graphically. Thank you, everyone.